Okay, so we're going to look at how we actually calculate standard deviation. Now, you're not going to be asked to remember this formula, but knowing how to use the formula and what's important from a standard deviation does help you understand where the values actually come from. So I need you to copy down this formula in your book. So we've got here SD, or it can also be the sigma sign, the Greek letter there, that. You might see it in either way, but I'm just going to keep it as SD for now. And then you've got X stands for a value, so whichever number you've got, so that could be a height of somebody, so it could be 62 inches. The mean, and we just looked at our mean just then as being, for the female was 63.8, so that is your mean. That is an X with a line above it. And then N is the number of people, or the number of people that were sampled, so it could be into the thousands, or it could be just 5 or 6. We'll try and get as many as possible, because obviously the smaller you have in your results, the more it's going to be affected by outliers, and we want to make sure we get a decent set of data, which is why I asked you all to contribute to the Excel spreadsheet. So pause the video before you move on, make sure you've got a copy of that formula, and I would like you to also make sure you know what the different symbols mean in it. Oh, I should have also pointed out, in case some of you aren't sure, this symbol here means sum of. So it means the addition of all of the number minus the mean squared, divided by n minus 1. So we're going to have a look at calculating the standard deviation for these lovely 6 cats here and their tail length. So you've got here your number of cats in this particular instance, so n in this instance using the formula before equals 6. And you've got your tail length here of the different cats. So you've got cat A, it's got tail length of 18 centimetres, cat B 22, C 21, D 24, E 23, and cat F has got a little short 16 centimetre tail. So get a copy of that table into your books so that you've got that to refer to when you come back to looking at your notes. So let's look at how we calculate standard deviation then. So you've got your cats here, A to F, and their tail length. First thing that you need to do is calculate your mean. So remember, that is this one here, X with the funny little line above it. So the mean length of the cat, add them up, divide by 6, you should get a mean length of 20.6. centimetres. Okay. Once you've done that, you can write out the first part of the sum. So this top bit up here, I'll just highlight that in yellow. So we're just going to look at just this section to begin with here. So those are the sums that you need to do for each of the cats. So I'm going to do A for you over here, and I would like you to do the rest of them. So A equals, so cat A, so we've got the number, so X is the number, so the sample, the value, so 18 minus 20.6, which is our mean. Now that's going to give you a negative number, but if you remember from GCSE maths, if you square a negative number, it becomes a positive. So our X minus X with a funny line squared is 6.76 for the first cat. So pause the video now and complete B to F cats, and then I'll reveal the answers on the next slide so that you can see whether you got the answers right or we're doing the sums correctly. So these are the answers that you should have got here. You should have 6.76 for cat A, we already did, 1.96 for cat B, 0.16 for cat C, 11.56 for cat D, cat E 5.6 and cat F 21.16. So what you need to do is add all those numbers up now, because that's what this sum of is. So we've done this first section here, x minus x with a funny line above it, squared, but we want the sum of those numbers. So all you need to do for sum of is literally just add them up. Then we're going to divide that by 5. The reason why it's 5 is because we had 6 samples altogether, but our n minus 1 over here, so we had 6 minus 1, that gives us the 5. Then once you've got your answer, square root that answer to get your standard deviation. So check whether you've done that right, pause the video while you do it, and I'll reveal the answer on the next slide. So hopefully you got an answer of 6.8 centimetres for your standard deviation. So that means that the vast majority of cats will be within 6.8 centimetres of 20.6. So in terms of our cats, we'd be looking at 27.4 in one direction and 13.8 in the other direction. Sorry, maths was a bit slow there. Okay, so surprisingly, we actually had to calculate this in our GCSE exams. So it's something that we learned back then, but they don't seem to do it at GCSE these days. So we were looking at the start of the lesson about the 2 different types of statistics. So we've got descriptive statistics, us describing the data that we received, and that's what you did yesterday. Yesterday, the whole point of your data collection was to get the hang of something called unbiased data collection. Quite often exam questions do count the methods that you've used to acquire data, so therefore it's really important that you've had an opportunity to actually do a random sample, because that is something that they are often looking for in results taking. Have you thought about taking your results without bias? So yesterday we got a range of 5.92 millimetres. So the thinnest grass leaf was 0.5 and the widest one was 6.42. Now, mean grass width then was 4.1 millimetres. Now, luckily for you, I'm not going to ask you to calculate the standard deviation using that formula in the previous slide for over 70, 80 sets of data. I've got a formula that you can use on an Excel spreadsheet. You just put the number in, you put your cells that you want to do the standard deviation for, and it does it for you. So nice and easy. We've got here our standard deviation is 1.9 millimetres. So that's saying that the 68% of the grass that you guys sampled yesterday would have been in between those two, would have been either side of 4.1 millimetres, 1.9. So most grass would have been between 2.2 and 2.2 and 6 millimetres. So if we looked at that on a standard deviation graph, then here, if we've got here in the middle, 4.1 is our average, and in this direction here, we would get up to 6 millimetres, and in this direction here would be 2.2 millimetres. That should be the same length, sorry guys, let me go and make it maybe the same length there. So 68% of your data would have been in that region there. And then if we get another standard deviation, our second deviation from the mean, we would see a line here, and that would take us to 7.9 millimetres over here, and same in this direction here. So 95% of the grass sampled would have been between 0.3 millimetres and 7.9. That is quite a wide distribution around the mean. It fits perfectly with the bell curve here. There wouldn't have been much grass that's sampled that were less than that, but we've also got to think about the fact that actually did we have tools that allowed us to measure grass that was lower than 0.1 of a millimetre, possibly not. I wouldn't think that any of you have a ruler or would have gone to the extremes to use a microscope to work that out. Same on this side over here, we've got the opposite. There wouldn't have been many grass strands that were wider than this over this at this end here. So that's your standard deviation of your grass samples from yesterday. Thank you for those people that contributed to those. So I had a little bit of an ulterior motive with you doing the grass sampling yesterday. So I bought this product here for my lawns. I've been working really hard on improving my grass over the last few weeks because that's what a sad 35-year-old does when they've got too much time on their hands. But what I want to know is actually, is it effective? So I thought, with you guys all living in the Macclesfield area, some of you I know do live further afield, we all have similar soil and we have all have very similar conditions. Obviously there's many factors that we're not able to control here, but just in this particular instance, to make our data worthwhile, let's use this as an example. So what I want to know is, does this impact the mean width of grass growing on lawns in the Macclesfield area? So with coming up with a question when we're looking at a particular question in biology, we come up with these things called null hypotheses. You've probably come across a hypothesis before at GCSE, but as you progress through your sciences, you'll see that it's more important to use something called a null hypothesis, which we can then decide whether we reject or accept or not. So a null hypothesis says there's no significant difference between the two groups of any observed differences are mainly due to chance or sampling error. Now, the opposite of that is the alternative hypothesis. And that's where you're saying there is a difference between the two groups. So what I would like from my lawn feed that I bought, I would like to see that my grass is significantly different to yours because I've spent the money and time doing putting this grass feed on. So I'd like to see if there is an observed difference. And that so the alternative hypothesis is basically the opposite of the null hypothesis. So I'd like to pause the video now and I'd just like to have a go at writing a null hypothesis for and an alternative hypothesis for the grass feed experiment. So I'll reveal what I put as my null hypothesis, and hopefully you got something similar to this. So I said there is not a significant difference between the width of the grass, because that's what we're measuring, when given supreme green and the other lawns. Any differences are down to chance or sampling error. So something along those lines. The bit that I've highlighted there, they're pretty much the key words that they're looking for in exam questions. So if you've not written those in, correct your work, and I'll be expected to see that correction when you hand in your work as well. Or maybe put a note in the column, important information, make sure you include this in an exam answer. They're looking for the idea of significant difference and the idea that it's down to chance for a null hypothesis. So here is the data that I gained from the grass outside. I took 13 samples altogether. I used the non-unbiased approach using the random sampling to make sure that I chose random pieces of grass in the garden and not just the areas where it's growing really well. So down here we've got the 3.2s. They're not particularly grown particularly well there. But what I would like you to do is I would like you to then have a go at the standard deviation like I taught you earlier. Now it might be easy when you've got such a large number to use a table like I've given you here. It just gives you an opportunity to keep it all together and follow your routes. You don't have to use this table, it's just there for some of you that may be struggling with it. So remember, once you've done this final column here, add this column here. I thought I had my highlighter on. So once you've done this final column here, once you've squared all the numbers in the previous column, you want to then do the sum of that particular one. So the sum of x minus x minus the x with the funny line on it squared. So add all those up. Then your n is your number of samples. So in this particular example, n equals 13. So n minus 1 is going to be 12, and then don't forget to square root your answer afterwards. So if you remember from the formula, it's a square root once you've done all the other things. So sum of, once you've done the sum of, divide it by 12, then square root what your final answer is. Now that you've got your data for your standard deviation, we're going to look at how we might display that in a chart and what the significance of these charts are. So I would like you to draw for me a graph. Now, I know some of you aren't going to have graph paper, so do your best using the line paper in your book. As you can see here, we've put your lines on here. So we've got 2 bars, the mean average width for the students' gardens and the mean average for my garden. So plot that onto a graph, really simple bar chart one, and pause the video while we do that. Okay, so now that we've got the graph plotted, we can see that supreme green is looking quite promising. There is a big difference in the mean of my grass width and your grass width. But what we've not taken into account is the standard deviation. Now, if you remember, your standard deviation is one standard deviation is the amount that the mean varies. So 68% of your samples will have fallen either side of this mean of 4.1. So what you need to do is you need to add your standard deviation bars onto your graph. So we've got 4.1, add 1.9, which is what yours was. That takes us up to 6. And then if we look, we have to go the opposite way as well. So take it down by 1.9, about there, 2.2. So there's a big range. So I told you that previously, that there's a big spread about the average. Now if we add that again onto my standard deviations, which hopefully you guys figured out as 1.6, well that would take us up this way to 7.45, and in this direction down to 4.25, around here probably. So I'd like you to add on those standard deviation bars onto your graphs. Now these are the sorts of things that people miss in exam questions. They might show you a bar chart of mean averages that doesn't have these bars on it, and if it doesn't have those bars on it, they're probably wanting you to look for those bars and say why you think that the data may or may not follow a specific conclusion. So sometimes they'll say Mrs. Needham came to the conclusion that her grass feed was better for grass growth, and you would say no, it's not. The reason for that is because of these standard deviation bars here. There's an overlap. The overlap comes here. Look, like I measured some grass, or a vast majority of my grass, 34%, over 34% of my grass was the same length as the grass in your gardens, and the same for you. Some of your grass here was actually above my mean. So there is no significant difference. So just want you to record this information now. So I'm going to show you 2 slides which cover that. So here, if your error bars, so sometimes they're called error bars because you can also calculate the standard error using standard deviation, so it just depends how you do that. You just divide the standard deviation by the square root of the number of samples, but don't worry about that. You don't actually need to know how to calculate error, but you do need to know what these bars are and why they're important. So if they overlap, then it means that you can reject that null hypothesis. So this is just an example of another type of graph. But if they do overlap, you have to accept that null hypothesis. So if we think what our null hypothesis was that there was no significant difference and it was down to chance. So basically, my results, my grass, there is no significant difference between the width of my grass and your grass. So I'm not quite sure whether I think it was only £12 I spent on my supreme green, and all the time I'm not sure whether it's been useful or not in terms of width of grass. In terms of greenness though, it's definitely worked. So this is how you would then use standard deviation to actually look at your data. So to finish off, I would like you to tell me, using the ideas, using data from the graphs, whether supreme green is significantly different. Remember those keywords that we underlined earlier. Now I'm going to give you some exam questions and some practice on this, so I want to see whether you understand it. If you've got any questions, you can email me or send me a message on Show My Homework. Do remember though, on Show My Homework that I have got other classes as well, and sometimes if I can get like 40 or 50 notifications a day of students who are completing quizzes or sending me messages. Sometimes some might get missed. It's not on purpose, but do please message me, and if you're struggling, it's just an introduction to standard deviation today. Thanks very much. Hope you enjoyed that video and it was useful for you to explain it. I will look for your submissions as a picture of your notes plus the exam questions that you've had a go at.